Section 2.1, we're going to talk about parallel lines and transversals. You guys should be familiar with parallel lines. Parallel lines are coplanar lines that do not intersect. Coplanar means they lie in the same plane, which is a flat surface that stretches out in all directions, and they never intersect. Here's an example of some coplanar lines. Skew lines are another type of line that do not intersect. Skew lines, for example, could be the top corner or top edge of this cube and then the bottom, no, hold on, wrong one, the bottom front edge of this cube. Those two lines are never going to intersect, but they do not lie in the same plane. This is in the top face, which is the top plane. This is in the bottom plane. They don't look like they're parallel, but if you think of them in 3D space, they're never going to intersect. There's some other examples of coplanar lines we could give from the same figure. Parallel planes are planes that do not intersect. So if you're thinking of this cube again, the top face and the bottom face are parallel planes, or the left face and the right face represent parallel planes. Okay? So if we're looking at number 1, we're supposed to name 2 planes that are parallel. You need 3 letters to name a plane. So, for example, if I wanted to use the top face of this rectangle, I could name that plane HGC. So HGC is that top face. I also could name that HGD, DCH. I'm just picking any 3 letters that lie in that plane. The bottom plane would be the plane that is parallel, and we could call that plane EFA, or lots of other ways, FAB, BEA. Those would all be names for the bottom plane. So those 2 planes are parallel to each other. Now this is not the only answer I could give. The left face and the right face are parallel to each other. The front face and the back face are parallel to each other. For number 2, it asked me to give an example of 2 lines that are skew lines. So these need to be lines that do not look like they're parallel, but if we think of them in 3D space, they're not going to intersect. So for example, HD, line HD right here, and line CB. These lines are never going to intersect. They look like on our paper they're going to cross right here, but this line is behind this front line. Whenever we name a line, we can either name it like this, line HD, and line DC, or we can use this symbol. We can say HD and BC. It takes 2 points to name a line. Number 3 asks for 2 lines that are parallel. For lines to be parallel, they have to be in the same plane. So, for example, EA and HD. Those 2 lines would be parallel. So, in this case, EA and HD are parallel. So, let's put that as one of our answers, EA and HD. Now, something else that you need to consider is that parallel lines don't have to have a face drawn through them if we're thinking of like looking at this rectangular prism here. So if I am looking at these points here, the line HG is also parallel to AB. Now, those points appear to be in different planes. This is in the top plane, this is in the bottom plane. But if you think, we could draw a plane that's diagonal, that goes through the rectangular prism in this diagonal manner, and HG and AB would both be on those planes. So we could say something like line HG and line AB. There are lots of other examples there in that figure, but this just names a couple of those. Alright, so a transversal is a line that intersects two or more lines in a plane at different points. So, first we just need to decide what a transversal looks like. So in each one of these, I want to know if line B is a transversal. So here, I can see that this is line B. And if we look at the definition, it says it's a line that intersects two or more lines. This intersects two lines in a plane at different points. This does not intersect those lines at different points. It's all at one point. So this is no, it is not a transversal. For the second problem, line B is right here. Line B intersects two or more lines. It intersects both of these other lines, and it intersects them at different points. So line B is a transversal for number 2. For number 3, I have line B here. This line only intersects one line, so it is not a transversal. So this is a no for line B. However, if we look at number 3, there is a transversal in number 3. It's just not line B. If you look at this line right here, that line is a transversal. But these questions were asking us about line B. So whenever we have a transversal that crosses two or more lines, we have special angles that we're going to be concerned with. So I've got this picture here, and I have labeled all of these with numbers. So for this figure, our exterior angles are angle 1, angle 2, angle 8, and angle 7. So all of those are exterior angles. They're on the outside of the two lines that are being cut by the transversal. That makes the interior angles angle 3, angle 4, angle 5, and angle 6. And the symbol that I'm using here is the symbol for an angle. Now, consecutive interior angles, that word consecutive means on the same side. So, for example, angle 4 and angle 5 are consecutive interior angles. They're both interior angles, and they're on the same side of the transversal. Or, I could use angle 3 and angle 6. Alternate exterior angles, the word alternate means on opposite sides. So these are going to be exterior angles that are on opposite sides of the transversal. So, for example, 1 and 7 are alternate exterior angles. And angle 2 and angle 8 here are also alternate exterior angles. Likewise, we can have alternate interior angles. Those are interior angles that are on opposite sides of the transversal. So examples here would be angle 3 and angle 5 are alternate interior angles. Or we could say that angle 4 and angle 6 are alternate interior angles. The last type of angle that we have is a set of corresponding angles. Corresponding angles are in the same location. So if you think of these 4 angles right here and these 4 angles right here as separate groups, the top left angle for both of these groups is 1 and 5. Those are corresponding angles. So angle 1 and angle 5 would be corresponding angles. Also, angle 2 and angle 6 are both in the top right corners of these intersections. So angle 2 and angle 6 are corresponding angles. Angle 4 and angle 8 are corresponding angles. Or we could say that angle 3 and angle 7 are also corresponding angles. So we're just going to do a couple problems here. This time I've got 3 different lines that are cut by that transversal. And my question asked me to describe the relationship between each pair of angles. So I'm going to begin by angle 1 and angle 8. So angle 1 and angle 8, notice this has nothing to do with this line down here at the bottom, so I'm going to ignore it. If I pretend like that those lines right there are not there at all, in fact, let's put a black rectangle over it. Let me change the color here so that we don't even have to look at this part anymore. Well, okay, so angle 1 and angle 8, these are both on the outside of the 2 lines and on opposite sides. So these are what we call alternate exterior angles. Okay. Next, we're asked to look at 8 and 10. So let me move my black rectangle here. 8 and 10 are right here. Now this time, this does not involve these top angles right here. So I'm going to ignore that they're even there. If I'm only looking at these 2 angles, both of these are interior angles, and they're on the same side. We call those consecutive interior angles. Okay. Our next problem asks us about angle 3. Our next problem asks us about angle 3 and angle 7. So if we look at those, angle 3 and angle 7 are here. This does not concern that bottom rectangle, so let's completely ignore it. Now these angles, they're both on the same side, but one's interior, one's exterior. Notice if we look at the 2 intersections here, they're both bottom left. So these are what we call corresponding angles. Angle 5 and 6 are up next. Again, we are ignoring that bottom rectangle. Now 5 and 6 we actually did not list earlier. They are none of the ones that we listed earlier, but they're one that you learned long ago. 5 and 6 together make a line, so they're what we're going to call a linear pair. That should be a term that you have heard before in prior math classes. For number 5, I have 1 and 12. So I'm looking at here, I'm looking at 1 and 12. This time, it's actually that middle line that I'm really not looking at all. So let me make it a little bit smaller. I don't care about anything in the middle. I'm pretending that that's not there. It's a little harder to block that out of your mind, but just pretend that it's not there. 1 and 12 are exterior angles, and they're on opposite sides of the transversal. So those are alternate exterior angles. Next up is 3 and 10. So for this, we're looking at 3 and 10. Again, we are not paying any attention to those middle angles. So if we try to pretend that line's not there, 3 and 10 are both interior angles, and they're on opposite sides of the transversal, which means that they are alternate interior angles. And then finally, we've got 9 and 12. So 9 and 12, I'll highlight those here. 9 and 12. Actually, these don't really involve 2 pair of lines. We could ignore everything up here. This is another set of angles that we did not list in the prior slide. These are ones that you learned about in prior math classes as well. So 9 and 12 are a special type of angle that we call vertical angles. You do not have to have a transversal to have vertical angles. Anytime you have two lines that cross, the angles that are opposite each other here are vertical angles. So 9 and 12 are vertical angles.